So we are doing a very important and a very interesting sum. Let's see the sum. It says if AD and PM are medians of triangles ABC and triangle PQR respectively, where triangle ABC is similar to triangle PQR, prove that AB upon PQ is equal to AD upon PM. This is what you need to prove. First thing is, what do you mean by medians when you say median? You know what is a median? Yes, median is nothing but, it's very simple thing, a line segment which joins a vertex of a triangle and the midpoint of its opposite side. That is what we know. That means what can we say about BD and DC? If AD is a median, we know that it is going to be equal. So we know BD is equal to DC and we can say it is half of BC. Beautiful. Same way, if PM is a median, then what can we say about QM and MR? We know that they are equal, that is QM is equal to MR, and we can say QM is equal to MR is equal to half of QR. So this is what we know in the sum, and we know one more thing, that triangle ABC is similar to triangle PQR, right? And we need to prove AB upon PQ is equal to AD upon PM. If you look at that particular two proof, we already learned in any sum, whenever we want to write the products in the form of a ratio, we have learned that the numerator should form one triangle and the denominator should form the other triangle. This is what we know. Right? So observe this, AB and AD, it should form one triangle. Does it form one triangle? Observe AB and AD. Yes, which triangle? Yes, that is triangle, nothing but ABD, right? So this is one triangle we need to prove similar to another triangle. Which one? Let's check the denominator. Now PQ and PM, does it form one triangle? Observe that. Which triangle? Yes, that triangle is nothing but triangle PQM. That means we have got the two triangles which we need to prove similar. That is triangle ABD similar to triangle PQM. So our job is to prove triangle ABD similar to triangle PQM. The moment you get it, you're going to get the proof. Right? So the focus is very clear. We need to prove triangle ABD similar to triangle PQM. Now we're going to find the required pairs to prove this similar. So for that, triangle ABC is similar to triangle PQR given to us, right? Now from these two triangles, we know that we're going to get the ratios equal. Which ratios? AB upon PQ, this ratio is equal to BC upon QR. These two ratios will be equal. You know why they are equal? Because they are the corresponding sides of similar triangles. This is something which we know. From this, let's pick up. You know what is BC information we have? Yes, we know that BD is equal to DC is equal to half of BC. So from that, if we say BD is half of BC, right? So from that, what do we get? We know that now BC is nothing but it is twice of BD. This is what we have as information. And this will be our equation number 2, right? Same way, in the other triangle for QR, do we have an information? Yes, we have QM is equal to MR is equal to half of QR. So from that, we can say that QM is equal to half of QR. So what is QR equal to? So we can say that QR is nothing but it is twice of QM. And this will be a statement number 3, right? Now this is something which is going to help us to substitute in equation number 1, that 2 and 3. Let's observe how we are going to do that now. So we substitute that, the value of BC in statement number 1 and the value of QR in statement number 1. Let's do that. So what do we get? AB upon PQ is equal to twice of BD upon twice of QM. We will get it as statement number 4. From where? From 1, 2 and 3. So now what happens? 2 and 2 gets cancelled. So we have AB upon PQ is equal to BD upon QM. And you know what? That angle B and angle Q, are they equal to each other? You know why? Yes, because they are the corresponding angles of similar triangles, and that's our statement number 5. You know what? Now we can prove those two triangles, those four triangles to be similar. Let's do that now. In triangle ABD and triangle PQM, we already have AB upon PQ is equal to BD upon QM. From where? From 4. And we have angle B is equal to angle Q, and that is from statement number 5. So now we can say that these two triangles, that is triangle ABD and triangle PQM, are they similar? Yes, they are similar. By which criterion? But they are similar to each other by SAS criterion, and we write there, therefore triangle ABD is similar to triangle PQM by SAS similarity criterion. Now you got it similar? But Now once you get it similar, now we will get what we wanted, those ratios which we wanted. So let's take that now. So now we'll take the ratio which we wanted, that is AB. So corresponding side would be PQ. So AB upon PQ is equal to, that is what we want, that is AD upon PM, and this is what we were actually supposed to prove. You know why these ratios are equal? The reason is corresponding sides of similar triangles. This was the proof. A very important but a very interesting one. Easy, right?